Hey everyone, it's John, and today what I want to do is begin a short video series on ISIS. So I suppose I should say, well, why am I doing this? Well, first off, ISIS is still absolutely huge in the ISP world. Whilst OSPF is the predominant protocol within the enterprise, within the ISPs, ISIS along with BGP is still absolutely massive. So I think if you want to get a job with an ISP, with a service provider, it is so advantageous for you to learn this. It gives you such a leg up on the resume to say, listen, I know ISIS, it looks good. And like I say, just beyond that, just by learning ISIS, I think it demonstrates initiative on your part. You're not just learning what you have to. You need to learn for your Cisco exams, EIGRP, OSPF, RIP, and BGP. By going out and learning ISIS, I think it shows great initiative and it shows you really care about routing and understanding it all from a deep level. Okay, so from the start, just by learning this, I think it's good for you to have in your back pocket. Now, here's the dirty little secret with ISIS. A lot of people are terrified of it, scared of it. They seem to think it's this very obscure and complex protocol, but the thing is, it's actually very easy. There's just a few things you need to iron out at the start, and once you get that in your head straight, it is so simple. It's actually very intuitive, and in my opinion, personally, I actually like it better than OSPF. I think it's more flexible. That is my genuine opinion. Now, what I want to do is, what I've learned is that from researching this, it seems like a lot of people who teach ISIS get really into the weeds very early, and I think, whilst it's very important, I think it can also be discouraging. People are talking about just where the protocol came from. It came from the OSI protocol, and not the model, the OSI protocol, and it was adapted for TCP/IP, and this is all very important. So you need to know this eventually, but I think to start with ISIS, I think the best thing to do is to look at a topology and just start mapping it as to how it really works, and that's what I intend to do here to help you understand that. Okay, doke. So the first thing you're going to notice visually is that ISIS routers, the difference between OSPF and ISIS straight away just by looking at it, is that you can see that the areas look more like BGP with autonomous systems, whereby the router belongs to an area entirely, whereas, let me just demonstrate that. With OSPF, let's say you had a few routers here, okay? And you had these interfaces here, all within, maybe call it area 0, the backbone, okay? And then from here, you would maybe put this interface here in area 2, and this interface here in area 5, and this interface here in area 37, whatever, okay? So it's interface based. You put each interface in different areas, and that's not the case with ISIS. With ISIS, you would have a router here, and a router here, and a router here, and they would be in their own areas. Okay, and they'd have some routers within their area, but if they want to talk between areas, they're going right across, like BGP within different ASs. You're just talking across areas completely. So that's the first visual difference, but trust me, this becomes really intuitive once you see it in action. Now, what I want to say is, as well, as my key points highlight, there's 3 types of routers which you can have in ISIS. Now, the first one is called a level 1 router, okay? Now, a level 1 router is just keeping information about routers within its own area, okay? The second type of router you have is a level 1/2. This router is it's able to talk within its own area, and it's able to talk between areas. So that's kind of like the ABR and OSPF. If you want to talk to a different area, you need that router to be configured as a level 1/2 router, okay? And the last one is called a level 2 router. Now, these ones you don't really see unless the network gets really big. And those networks, the level 2 routers, sorry, you would configure them as your kind of core backbone. They would just be there just to hold summary routes, because what the level 2 database does is it holds information about all the areas. Level 1 holds information about the routes within an area. Level 2 holds information about routes outside the area. So a level 2 router just has kind of summary routes about all the areas. Level 1 is just your a normal internal OSPF router, just knows about the routes within its area. Level 1, 2 is like the ABR, it knows what's in its own area and it knows outside. So level 1/2, they know the most, but they've got to carry the most information, okay? Level 2 is good when your topology becomes so big and you have so many routes summarized that it's impractical to have routers be level 1 and level 2. You want to just have dedicated level 2 routers, okay? So that's the first thing, okay? So in the case of this topology which we've got here, the way this is going to be is that we're going to have a level 1 router here within area 2, and this one's going to be level 1, okay? Now because this router here is going to speak to a different area as well as routers within its own area, this one here is going to be level 1 and level 2. That means it can talk to level 1 routers, which are these ones, and it can talk between different areas, okay? So this one can talk to different areas here. Now, like I say, level 1, level 2, that's going to be like your ABR and OSPF. So similarly, if this router here is going to be able to talk to different areas, i.e. this area here and this area here, well, it's got to be configured for level 1/level 2, okay? And the routers in here, these just need to know about their own internal areas, own internal router, sorry. So this will be level 1 and level 1 as well. Same again, this router here needs to talk between different areas, so it's going to be level 1/level 2. And these ones here will just be at level 1 and level 1. Now here's the thing though, right? There is absolutely no harm in you configuring every router, every single one, to be level 1/level 2. You can make every router that way. That means every router can talk to everyone. But the thing is, for efficiency, it's much more efficient when you think about it, is that these routers here, if they want to talk to a different area, there's only one path out and it's going via this router. So it's easier to say, you only need to know about the exit path is going to here. So you can be a level 1 router, and this can be a level 1/2, because this is going to be this is the only router that needs to know about all those areas. Level 1 routers will just get a default route pointing to the nearest level 1/level 2 router, okay? So what you're going to see here is, in the case of this router here, it will see the address of this, or the IP addresses of this router, but see for any external routes, it's just going to have a default route pointing to the level 1/level 2 router, okay? Same here, this will have a default route, this will have a default route pointing to its level 1, 2, and these routers here, these three, they will know about everything, so they can talk between each other, no problem at all, okay? So that's the first thing, and like I say, it's going to take a little bit of time to let that sink in, but hopefully by the end of this series, you'll get it. Now the next thing what I want to do is tell you about this thing called an NSAP address. Now this is the part people get confused about, or not confused, they get discouraged because they think it looks confusing. So if you've seen ISIS configured before, what you're going to see is people typing in this net command, and it's going to look something like this. And you're going to think, wow, that looks pretty confusing. Now I suppose it might do on first glance, but that's because you maybe just don't know how to read it yet. Now it can be broken up into 4 distinct parts. Now the first part here is 49. This is like a private IP address, and in ISIS, it will always be the same. So every ISIS is always going to be 49. See the last one up here, the .00? All that means is you're talking to another router, not a switch or a PC or what, it's always a router. So ISIS is always going to start with this 49 dot, and it's always going to end with .00. So the only things you need to be concerned about is these things in the middle. Now the first one here, okay, this part here, this is an area ID, okay? So in the case of this maybe would be area 1, because you've got 0001, and if it was area 2, it would be 0002, and if it was area 3, it would be 0003, or alternatively, you can make it match your own syntax as you want. You can make area 1 be 1111 and area 2 2222 and area 3 3333. It doesn't matter as long as you keep it consistent throughout your topology. Now, the last part is this part here. This is the system ID, and this part has to be unique. Now, it's common best practice to basically make this like the loopback, and I'll explain that in a later video. But all you really need to know is that this part has to be unique. So in this video, what I'm going to do is in the case of router 1, I'll make these all 1s. In the case of router 2, I'll make these all 2s. In the case of router 3, I'll make these all 3s, so on and so forth. And that will be your basic NSAP address. After that, you just need to specify what interfaces you want to advertise in ISIS, and that is pretty much it, okay? So, like I say, we're going to discuss more of this in more detail as the videos progress, but I thought let's just get cracking and you can see ISIS in action, okay? So let's look at the topology now with that basic introduction out the road. Now, we've got these addresses here. We've got 192.168.1.0, which is effectively, oh, I'm on the graphic there. Let me switch to the actual topology. There we go. Now, so you can see the configuration. So you'll notice that each router, for example, router 5 has got a loop back of all the 5s. Router 6 will have a loop back of all the 6s. Just a very simple standard format. Okay. And we've just got our basic IP address in here. So like this can ping show IP int brief 100.0.0.2. Okay, that's just a connected network. Okay, right across here. So these can all ping each other. They're all configured. That's the only thing I've configured, is basic IP addressing. If you want to follow along, just configure the basic IP address in here. Now what we're going to do is start by configuring we'll start by configuring router 1, okay? Now remember, router 1 is going to be an ABR effectively. It's got to talk between different areas, okay? It's got to talk to this router here and this router here, and they're in different areas. So this router has to be a level 1/level 2. Now, here's a kind of analogy I draw between this. When it comes to ISIS, level 1, they speak, imagine level 1 routers speak English, okay, like myself, and level 2 routers, they're bilingual. They can speak 2 different languages, and let's say, so if you've got a router in a different area, you need to pass the information to the bilingual guy who can speak both languages. He's like the translator, okay? So you can speak to guys in your own area, but if you want to speak outside your area, pass it to the bilingual guy, the 1/2 guy, okay? And he can talk to different areas and he will translate to a different area. Now, he can translate to his area 2 guys and they can speak their own language between each other, but if they want to speak between a different area, they pass it to the bilingual guy who can speak the different languages, okay? That's the basic way I like to conceptualize it. So, let's start and do this configuration then. So, we're going to do these commands, and it's pretty similar to OSPF, you'll see that. So we do configure terminal, router, ISIS, enter. Okay? Now, router 1, like I say, is going to be an ABR. It's going to be a level 1/2. It's going to be a translator. It's going to be able to speak within its area and between different areas. So we're going to do the command is IS type, and if you do the help context, you're going to see 3 options: level 1, level 1.2, and level 2. Now, like I say, level 2, we don't need to worry about them till the topology gets really, really massive, and you just want routers dedicated, core routers dedicated to just summarization. So in the case of this, we're going to configure this router to be at level 1.2, and that's it. It is now a level 1/2 router. okay? The next thing we need to do is give it that NSAP address which I was talking about. Now if you remember the format, if we come here, the format is going to start with a 49, okay? Now this router here is in area 1, okay? So the address is going to look like, this is the area part, remember? So we'll just do 0001, that's our area. Now we've got our 12 digits to go, and it has to be unique. So what I'm going to do is, because this is router 1, I'm just going to make all these, every one, 1. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and like I say, it always ends in a .00. That's the NSAP address for router 1. So let's configure that. And we do net, and you're going to get it here. So 49, and we're in area 1, 0001, and our ID is router 1, so we're 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 00. That's you. Now all we need to do is configure our interfaces which we want to participate in ISIS. And as you can see here, we're going to have gigabit 00, gigabit 01, 2, 3, as well as the loopback as well. So let's go and configure that then. So we'll do int range gig 00 to 4, and the command is IP router IS. That's it. Oh, is number 4 not configured? That should be it. That should have been to, the range was wrong there. I did an extra range there. That should be to 3, sorry. IP router ISIS. Okay, that would be it. And we also need to put the loopback in, so int loopback 0, IP router ISIS. That is it. That's the full configuration for that router. Now, let's configure the other routers within its area, and like I say, these can both be level 1/level 2 routers, but again, it's more CPU intensive. They need to hold more routes about different areas. Let's just make it super efficient and just make these level 1 routers. So they'll just have one database, the level 1 database, and they don't need to know about the level 2 database. They'll just pass all traffic out with their area to the nearest level 1/level 2 router, to their translator, their bilingual translator. So let's do router ISIS, and we'll do a ISIS type, and IS type rather, level 1. It's going to be a level 1 router, this one. And like I say, the NSAP address is going to be net 49, always going to be 49, and we're in area 1, so 0001. And this time, our 12-digit system ID, which has to be unique, we're just going to give it all the 2s. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And again, we've got to finish it off with what? 00, and that's it. Now we need to configure our interfaces, and the only interface configured is gigabit 03 and our loopback. So let's go and do int gig 03 IP router ISIS. Int loop 0 IP router ISIS. That's it. So let's move along to router 3, do the same thing. And we'll do enable configure terminal router ISIS, and we'll do IS type, and this is going to be a level 1 as well. And we'll do our NSAP address is 49, and we're in area 1, so 0001. And our 12-digit unique code is just going to be all the 3s, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and end 00. That's it. And now put it on the interface, we're gigabit 02 in this case, IP router ISIS, and we'll also put it on the loopback, IP router ISIS. That's it done. Let's slide along to router 4. Now router 4 is in area 2, so the NSAP address is going to be a little bit different. Router ISIS, and again, this is an area border router, so it's going to be a level 1/2 router, so we'll do IS type, level 1/2, and we'll do the NSAP address is 49, always 49, and this is the bit that gets different here, because it's area 2, it's going to be 0002 this time, and again, the 12-digit unique system ID is going to be all the 4s, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and end with 00. Now we're going to put the interfaces in, which is going to be gigabit 00, 1, and 2. So we'll do an int range gig 00 to 2, IP router ISIS, and our loop back as well is going to be IP router ISIS. That's that. And we'll go here, a router 5. Router ISIS. I'm going to do IS type, and it's going to be a level 1 router. And we'll do our net, it'll be 49.0.0.2 this time, and we'll do all the 5s. 00, and now put our interface in, so it's gigabit 02 in this case. IP router ISIS, and int loop 0, that should be. IP router ISIS. That's that done. Okey-doke. Enable configure terminal router ISIS, and we're going to do IS type. It's going to be a level 1, and we'll do our net. It'll be 49.0.0.2, and we'll do all the 6s. 00, and our interface is going to be gigabit 01. So int gig 01 IP router ISIS, and our loopback as well. We're going to advertise that as well. And that's that done. Let's slide along to here. Again, this is going to be an ABR, so it's going to be level 1 / level 2. It's going to need both databases to be bilingual. Router ISIS, and we'll do an IS type level 1, 2. And the net address here, remember we're now in area 3, so we'll be 49 again, 0003, and our 12-digit system ID is going to be all the 7s, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and again we end with 00. Now the interface is configured, it's going to be gigabit 01, 00, and 02. So int range gig 01 to 2. Yep, that's right. And we'll do IP router ISIS and int loop 0 IP router ISIS. What have I not got? A loopback on that? No, I'm not. I need to configure the loopback. Sorry. Int loop 0. I thought I'd put the loopback address on this. That should be that. And now these two are just going to be level 1 routers, of course, like I said before. So we do, let me just make sure I put the loop back on this as well, actually. Yeah, that's fine. Okay, so router ISIS, IS type is going to be just level 1. Net is going to be 49.0.0.0 on area 3, and we'll do all the 8s, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 00. And the interface is configured is going to be gigabit 00 in this case. IP router ISIS, int loop 0, IP router ISIS, that's that configured. And now we'll do router 9, the last one. Make sure it's got its loopback configured. Yep. So conft router ISIS, IS type level 1, net 49.0.0.3, one area 3. I'm going to do all the 9s, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 00. And we'll do exit, interface, gigabit, what are we on? Gigabit 02 this time. And we'll advertise this network. And we'll also put the loopback in, IP router ISIS. That's it. That's ISIS multi-area configured. And let's look at the address. So we'll have a look at the ABRs first. I'm calling them ABRs, the level 1, level 2 routers. So if we do a show IP routes, you're going to see these addresses. Now, actually I'll filter that. Show IP route. So the level 2 routes are basically external to us. So we are router 4 now, so you'll see like router 8 loopback comes through as a level 2. But you'll notice we're router 4, our loopback 6 and 5 will be level 1 because they're within our area, so that's a level 1 route. Where is 5? Yep, so 5 and 6 there, you see them? They're both level 1 because this is router 4 and 5 and 6 are within the same area, so that's level 1. Now, like I say, this is because as an ABR, a level 1 / level 2, that's got the database for the area with it, the area which it's in, area 2, as well as all the other areas. That's why the ABR here can see level 1 and level 2. If we go down to just the level 1 router, so for example router 5, the database is going to the routing table, sorry, is going to look a little bit different. See that? All we've got is information about routers within our area, which would be loopback 6 and loopback 4, and for anything else we've got a default route configure which points to the nearest level 1, level 2. So if it wants to ping, say, this one here, all the 9s, it's not got 9.9.9.9, but if you ping 9.9.9, it's going to get there no problem at all, because what it's going to do, it's just going to set a default route to the nearest level 1, level 2, which is the bilingual one. It goes to it looks up its routing table, and it sees, oh, I've got a path to 9.9.9.9, I can send it that way. So you see that? So that's the way you can configure. So all of these routers here, they've got this really nice truncated routing table, very, very efficient, okay? And they can ping right throughout the network. Ping all the 1s, ping all the 2s, you can ping everyone, no problem at all. And like I say, the only ones which have the full routing tables are the edges here, the level 1, level 2s. All the other routers have got these nice, tight, shortened, stable routing tables. And that's it. So that's the basic introduction to IS. Now, is there more to it than that? Yes, of course, but I think just by following this video, you've got a big understanding. The main thing that people just freak out about, that NSAP address, and it's so simple. So like I say, I would encourage you to lab this one out, do it, it's really, really easy, and you'll find that the IS is mega flexible, as we'll see in the later videos on its design, on how to design it rather. And yep, so that's it. So like I say, lab it up, try it out, and don't be scared. So thanks very much, and I'll see you guys soon. Bye bye.